Hello student, we discuss here thermodynamics, fill in the blanks. Here delta entropy change, free energy change, enthalpy change, delta S fusion, delta S vaporization, etc. we will discuss here. I'm Veena Dixit. If you like my video, please subscribe my channel. Decrease in free energy is measure of useful work done by the system. Okay, useful work done by the system. This is the fill in the blanks which I put here. A measure of useful work done. Now, effect of increase in pressure on entropy. If we increase the pressure on liquid, so what will happen? You have seen liquefied petroleum gas. It was gas and randomness was more. But when we compress it in a cylinder, so the randomness will be decreases. So delta S will be negative. It will be liquid. So means gaseous having more entropy as compared to liquid, and liquid having more entropy as compared to solid. So delta entropy delta S will be more for G, randomness more for G, entropy will be more for G than liquid and solid. Liquid has more entropy than solid, so delta S will be negative if we increase the pressure, because the state will be changed from gas to liquid. It can change, so disorderness decreases. Now delta U, that is internal energy change, is a state function. See, delta U is a state function, delta G is state function, and free energy change is state function. Enthalpy also, delta change in enthalpy is also state function, as well as extensive property. Okay, now because they depend on initial and final state. Now delta U is a dash state function. Delta U can be represented as Q plus W. Yes, it is true. And delta U depends on initial as well as final state by the system. So that is why the sum of Q plus W is a state function. Now internal energy change is a state function, but separately, individually, Q and W are not a state function. They are not a state function. Okay, so heat and work, they depend on path function. Now at equilibrium, delta G is equal to delta H minus T delta S. Because delta G is 0 at equilibrium, so when it will be 0, so delta H will be equal to T delta S. Okay, now T is equal to delta H divided by delta S. Now delta H vaporization is equal to delta S vaporization multiplied by what? So actually you should know about this. Delta S vaporization is equal to delta H vaporization divided by boiling point. So if they will ask delta H vaporization, so product of delta S vaporization and boiling point. So write down delta S vaporization multiplied by boiling point. So product of these two is giving you delta H vaporization. Like that, delta H fusion you can do. Delta S fusion is equal to delta H fusion divided by melting point. Internal energy is